warahmatullahi wabarakatuh. Hello everyone, welcome back to my channel. In this video, I will explain my summary about aeration, wastewater treatment with alum, and coagulation. Let's get started. For our first, I will explain about aeration. What is aeration? Aeration is a process of adding air or oxygen in water by bringing water and air into close contact, by spraying water into the air, or by providing fine bubbles of air and allowing it to rise through the water. So, aeration is a process of touching, contacting water with oxygen. Aeration is divided into two, namely natural aeration and artificial aeration. Next, this is aeration function. What it does when oxygen is pumped into the water is to increase the amount of dissolved oxygen in the water, so it is very beneficial for the body because it can reduce the ions that are not good in the water that we may drink. In biological aeration, there are many microbes in the water, with the milk still stomping the air with water. The microbes decompose organic compounds by pumping them with oxygen. They will turn into oxide, which still settle. This is a natural aeration in the river. Natural aeration looks like it shoots air waves into the water. If the wastewater treatment can use an air blower in the universe, the aeration process can be observed, namely the ripples of river. Namely the ripples of river water, which indicates that the water is shallow and there are many fish because in the area of the river, the oxygen is very high and favored by the biota. Second example of natural aeration is the wave on the beach. The process of aeration in sea wave, namely when the wave on the beach do not stop moving, we can see the presence of sand, namely fine grains that come from seawater, which will have high salt ion, which as a combination of alkaline earths such as MgCl, KCl, and halogens. This very also includes oxide. The sea is rich in ions, and when it emits oxygen from the aeration process, the process of aeration in the sea will enter the oxygen in the air into the air. When dissolved oxygen is high, not only the biota but also the fish benefit. Then when the dissolved oxygen is high, a process will occur, namely the minerals in the sea form the oxide and the oxide from our solids. And this is artificial aeration in the aquarium. The aerator in the aquarium will spray air in the aquarium, and when an experiment is carried out, the aerator is turned off for only one day. Then the water in the aquarium will be cloudy and cause the fish in the aquarium to die. In the artificial aeration, the use of aeration pumps in wastewater treatment system includes procurement of equipment from wastewater treatment such as turbojet aerators, surface aerators, centrifugal aerators, membrane diffusers, and air tube diffusers. The first, this is a turbojet aerator. This picture is turbojet aerator. Turbojet aerator produce microbubbles that are more effective in increasing DO levels in water so that POD and COD levels decrease according to the target. The air bubbles spread quickly and evenly. Easy installation, economical maintenance, save electricity, suitable for salt water, fresh, and pump waste. In the second picture is centrifugal aerator. This is the picture about centrifugal aerator. We can see centrifugal aerators create improved condition from dissolving gases into the liquid phase, including bubble size and bubble size distribution and duration of interaction with the liquid. Centrifugal aerator is used for water circulation, exchange, and aeration. In this picture, this is a surface aerator. You can see surface aerators work at the top of the pool, helping to circulate water, adding oxygen, breaking down algae, and dirt can accumulate on the surface. Releases water into the air, allow it to come into contact with oxygen and other gases, then is carried back to the pool. In the fourth picture, we can see this is a membrane diffuser. Membrane diffuser, diffuser and air diffuser or membrane diffusers is an aeration device in the form of a disc, tube, or plate, used to transfer air with oxygen which becomes industrial wastewater. Diffusers usually use a rubber membrane or ceramic element and produce fine or coarse bubbles. And the fifth picture, this is an air tube diffuser. We can see this is air tube diffuser. The air tube diffuser maximizes aeration efficiency by creating better air bubbles and wider surface coverage. Air tube provides higher oxygen transfer rates and a more efficient aeration system. And this is in the second, I will explain about water treatment with alum. Water treatment uses chemicals, namely alum, with the chemical formula Al2SO4. Processing method using alum or alum chemicals. In the first process is collected samples of dirty water from urban area. In the second process is the water given by alum turns clear and the dirt drops to the bottom. And the third process is after the filtering process, the water is very clear. The way alum works in water filtration is to collect dissolved particle in dirty water by removing the charge on the particle or neutralizing the particle so they can settle. The dirt dots are colored as dirty water and repel each other, with the presence of alum containing coagulant able to make it attractive and which can be layered or double layered. This means that the first screen is attracted and the second screen is attracted so that over time it becomes thin and large and then it will settle. And there are various kinds of water treatment, some to be discarded into the environment. Drinking water, sewage, fishery water, or industrial water. How to treat drinking water? In the first process to treat drinking water is screening, which is the initial process of entering water and filtering waste that is still raw. In the second process is coagulants flocculation, namely the provision of coagulant, namely alum and citrate and strip to make it easier to form a precipitate. In the third process is clarification or sedimentation, namely the accumulation of sediment or mud that settles into the sediment pool. In the fourth process is filtration, namely filtering a slow sand, where the sand will be filtered slowly. And the next summary is coagulation. This is the picture about coagulation, and this is a flocculant. Coagulation is the addition of chemicals to destabilize the electrostatic forces of non-soluble solids. Coagulants chemicals typically have a positive charge, which binds to the negatively charged particles in water, neutralizing them and allowing them to come together to form small clumps of particles called microfloc. In most cases, the chemical reaction occurs in a fraction of a second, so it's important the coagulant is dispersed quickly and evenly to encourage as many particle collisions as possible. Because this process relies on chemical reactions, several considerations must meet water temperature. For example, colder water usually slow. The next, coagulation and flocculation reaction, which may require more time to achieve optimal floc formation. Extreme values of pH, high or low, will also interfere with the process coagulant. Effectiveness is highly dependent on pH. For some coagulants, alkalinity is a factor. Operators may need to raise alkalinity for coagulation to be effective. When using iron or aluminum coagulation that can consume alkalinity and depress pH, when they are consume alkalinity and depress pH, when they are added to a low alkalinity water's turbidity is also important. That the lower the turbidity, the more difficult it is. For proper floc, the most common coagulant chemical used is aluminum sulfate, commonly called alum. When added to water, alum forms jelly-like particles of aluminum hydroxide. The trivalent aluminum ions neutralize and attach to negatively charged particles in water form microfloc. Alum works best in a pH range of 5 to 7. Polyaluminum chloride and iron salt, such as ferric chloride and ferric sulfate, are also used. They operate over a wider pH range, coagulants, and flocculants. Aids are added to improve binding, with stronger, more suitable floc and evert flocculation by increasing floc size, strength, and or floc density in addition. They help overcome the out of low temperature, reduce the amount of coagulant needed, and reduce the amount of sludge produced commonly used coagulant. Aids include cetogenic polymers. Polymers are defined as a synthetic compounds with high molecular weight and composed of repeating chemicals units or monomers. Polymers may be polyelectrolytes, such as the water-soluble flocculants, water-insoluble. Ion exchange resins are insoluble on charged materials. Polymers are long chains of molecules that produce highly charged ion and help bind microfloc together into large floc particles. They are very popular with operators because they are very effective and can be positive, negative, or neutral. A charge providing a great deal of flexibility in different circumstances. And that's all my summary about aerations, wastewater with alum, and coagulations. I hope my video can be useful and add insight. Thank you, and wassalamualaikum warahmatullahi wabarakatuh.